go. Hand wave.
Okay. Can you guys all hear us good? Come on in. Good afternoon. Welcome. I'm Mohan. I'm a solutions architect with Amazon Web Services.
And I'm Brett Francis, solutions architect as well.
So we'll talk about for the next hour about how to scale applications on AWS to 10 million users. And the way we are going to do it is start out small with a small application and then go through various building blocks and scale it up across multiple availability zones, adding a lot of services. We're going to talk about that, give you guys some tips, best practices, et cetera. There's still some spots up here if folks want to move up here. And then we broke this up into sort of 4 segments, and then Brett and I are going to basically go back and forth across these 4 segments to give you guys a little bit of variety and break it up along some themes. So let's get started. So scaling is sort of a big topic, right? I mean, there's lots of things to read, lots of things you probably are hearing. And so scalability of applications, it's sort of a big thing. Where do we start, right? I mean, a lot of people struggle, and if you're like most folks, basically you go into some search engine like Google here and say scaling on AWS. And as you can see, you get basically auto-scaling is the first topic that pops up. Lot of items to read, over 500,000 hits, right? And even though auto-scaling showed up as the first hit, it's probably not the place you want to actually start. By the way, this particular presentation has been already been given by a couple of our colleagues, and it's available on the web, and it's showing up actually on the second page. Maybe with enough clicks, it'll actually go up to the first. So back to auto-scaling. Even though it was sort of the first result on the top of the search, it's probably not a place you want to start. It's not a magic button that's going to fix scalability problems, right? It's a tool and a destination, and we're going to talk about where it fits in the grand scheme of things in our architecture and design. So where do we start, right? Back to our first question. So let's start with some basics, just to kind of lay the groundwork. Some folks may already know this. So AWS is broken up into regions. There's 10 of them around the globe. They are distinct, autonomous, separate areas. The 10th one is Beijing, China. We just announced a couple of months ago. And each of these regions are broken up into what we call availability zones, or AZ for short. Think of this as sort of like a data center, if you want to, that level of abstraction from a traditional IT point of view. Why is that important? And we'll talk about this from the architecture principle. When you think about designing applications, you want to put things in different availability zones to be able to do scaling, resiliency, availability. There's a whole variety of factors that come into play. So AZs are a very important construct as we talk about sort of architecture and design principles here. And last but not least, in the global context, we have what are called edge locations. There's about 50, a little over 50 right now. And these are basically points of presence around the world. It allows for content distribution network. We have one we call CloudFront, and also domain name service Route 53, so that users are closer basically to delivering that content, that you can get better experience through lower latency. We'll talk about some of these as we go through this particular hour. To give you a scale of where we operate, it's 2014 now, 10 years ago, back in 2004, when Amazon.com was a retail enterprise, about $7 billion in size, about 8,000 employees. You can imagine, we needed a lot of machines, a lot of servers, a lot of storage to run that enterprise. Today, in 2014, we are adding that much capacity to power a $7 billion enterprise every single day. That's pretty massive scale. So we also have over 30 services. And when we talk about services, we probably won't be able to cover them all today. We'll talk about quite a few, actually, in the context of our scaling discussion here. We think of these in sort of an abstract kind of a layered concept of looking at the global infrastructure that I talked about, regions and AZs, going through networking, databases, compute, storage, application services, and finally deployment and management tools. A lot of these are accessible through our console interface, and also through command line interface, CLI, and a variety of SDKs. So it's a very rich and robust ecosystem that you can use. And again, we'll go through some of these. So back to our initial hypothesis here of where do we start? Sorry. Starting from day one, single user, day one, that's you, potentially a developer, starting out building your application. And this is something that may be what it might look like. It's just a starting point. And you have your code, the web application, database management, all of that resides on an EC2 instance, which is a virtual machine in the cloud. And you have an elastic IP address, which is a static address through which you or other users can get to your instance through a Route 53 domain name service, okay? A very simple sort of a topology here. Now, as you're scaling, one of the issues that might happen is, well, the machine isn't big enough, right? Which happens often because more people are coming or you're testing and not doing other things. So you're going to vertically scale. In the EC2 family, we have about 20 instances now, and we break them up into different families, high CPU, high storage, high I/O. And this is to allow for different workloads that have different characteristics to be able to make sure they can use the particular EC2 instance that you want, okay? But at some point, you may choose the biggest instance, and eventually you will hit a ceiling. I guess
You might have hit something. There you go.
Sorry, folks.
There we go.
What happened?
Plug in. Screen.
Oh.
There we go. Screen.
I think we lost our
Lost our
slides.
screen? No, we lost our screen.
Maybe we can switch back
There
to
we go.
the,
There we go.
There we go.
Unplug. Plug. Classic.
I guess I needed another laptop for high availability, huh?
Classic troubleshooting. Is it plugged in? There we go. All right.
All right. Back.
Go fast. Go fast.
Okay. So at some point, you're going to end up reaching a vertical limit in terms of the ceiling of the largest instance. Then what do you do, right? The other issue with this particular design is everything you have, all your code, all your database, everything you have is residing on a single box, right? And so basically, there is no failover, just like we were experiencing here, unfortunately. And no redundancy, right? Any sort of application, as you're thinking about scale, you have to think about high availability, resiliency, failover, all of these standard sort of practices that we all know as IT practitioners, right? So a couple of dimensions we're going to talk about, scalability, availability, et cetera. One of the things to think about is breaking up the application, the web logic, from the database code, right? That's a fairly common starting point. So what you might want to do is to say, okay, I'm going to break that apart, put the database on a database instance of its own. Now, database is a big topic. We're going to spend a few minutes talking about some of the choices, et cetera. There's lots of choices on AWS. On the left-hand side, you will see self-managed, which is a bucket that a lot of folks choose, people who are familiar and well-versed in a particular technology. They may want to run a database on an EC2 instance, perfectly fine, doable thing, right? And you can even bring your own license in many cases from your enterprise or on-premise agreement that you may have with Microsoft or Oracle or whoever. The other three options are fully managed choices, and that's something that you might want to take advantage of if you're, again, a developer, let's say, and not worry about a lot of the heavy lifting that goes on with having to manage databases. The first one is Amazon RDS, Relational Database as a Service. We offer 4 flavors of that today: MySQL, Postgres, SQL Server, and Oracle. And there's a couple of choices there as well. If you want to run the RDS service, you can still bring your own license, or you can spin up a database where the license is already included. So that's one option. So basically, in the managed database world, we are installing the database, we are doing the patches, upgrades, backups, all of that heavy lifting behind the scene for you. So you're just worrying about your development code up at the top, right? If you decide to use a NoSQL option, we offer a solution called DynamoDB, which is basically a key value store, okay? We're going to talk a little bit about that later again. And it utilizes solid-state disk behind the scene. It's a super high throughput, low latency NoSQL choice, right? In the single-digit millisecond range. Again, every write you do, we replicate it behind the scene into at least 3 data centers, right? So it's always durable for you. You're basically accessing it through simple API calls, and you define how much read-write throughput you want. And then you have Redshift, which we announced about a year ago, which is data warehouse as a service. It is massively parallel petabyte scale warehouse, and it's SQL compliant. That's the beauty of it. It's wickedly fast. A lot of folks are using it for doing business intelligence, analytics, queries over long-term historical data patterns. Again, you just say how big a cluster you want, we spin it up for you, and you just do queries against it. So lots of choices and a pretty full landscape of things that we're going to dig into and talk a little bit about some of this. So I'm going to hand it over to Brett for a few minutes for the next segment.
All right. Hi, everybody. So in this segment, we're going to go through some of the building blocks, because although you're at the one user point in this trajectory, we did start talking about decomposing this into pieces that can scale independently. One of the earliest choices that we work with customers a lot on is which technology to choose from a database perspective. There are 2 big categories. I'm sure you're familiar with both. There's SQL and NoSQL. I don't know if everybody's going to like this, but pretty much the recommendation that we would say as you're scaling through your trajectory is to start with SQL databases. Unless you already have skilled staff, a SQL database, just at the end of the day, there's a lot of people in this room who know SQL. There's a lot of people out there who know SQL. And although NoSQL, we'll talk about this in a bit, is right for many things, when you're starting out, the availability and access to people who can help you becomes a very valuable thing as you're going through your trajectory. So it's not that one or the other technology is there, it's with maturity and availability of resources often is where we see people getting into tough spots. So I would recommend if you're looking for just an open-ended answer to that, start with SQL and then keep learning NoSQL where you can. So why would you start with SQL? A notch more detail. As I mentioned, there's a lot of capabilities in this room. I'd say the technology itself is maybe even older than a fair number of you in this room. So there's a good maturity with it. It has been scaled up and down many, many times by thousands and millions of companies. There's a thought that you might break SQL later on, and pretty much, at least for this talk today, there are many tools available to you to help you not break it nowadays, a very mature environment. And pretty much unless you're operating at massive scale, SQL can handle it. It's a great place to start. So you might have noticed my asterisk of massive scale. So let's define that a bit. What is massive scale? Because you have it. The way we define massive scale is if you're adding 5 terabytes of data a year or more, would be one characteristic, or you have incredibly hot data of any level of scale. Let's call it a few hundred gig to multiple terabytes as well. So there are often situations where you might have that, but for the most part, most applications in that 1 to 10 million user range actually don't end up with that, particularly in the early days when you're just getting started. So now, why would you use NoSQL? Let's say you do have hot data. Let's say you do have a real need for some super low latency portion functionality of your application. It's definitely fantastic for that. If you have metadata-driven data sets, or if you've got mismatched record sizes for all these kind of capabilities, you might also have a rapid ingest of data phase of your application, but that wouldn't preclude you using SQL in other places as well. So one side here is there's a difference between running a NoSQL database for your application purpose and administering NoSQL databases at scale. I would recommend in your heads, if you take that away today, that is a very valuable thing to make sure that you treat those separately. Just because you might find yourself having a need for NoSQL is not the reason to say, well, I have to suffer through the burden now of administering it as well. So go find the services that are out there. Of course, as Mohan mentioned, DynamoDB is one that we offer, but that administrative capability built in, you get to leverage then the knowledge that's being built in the service development shops that are doing NoSQL as a service, instead of having to go for the 30-year trajectory like the SQL has over the years of scaling it to very, very large scale. So it's a way of leveraging things, and we're going to keep on that kind of theme of leveraging others and not inventing it yourself if you can, as a key tenet to scaling on this trajectory. So let's get back to the main now. Let's see how far we can take SQL at the core of this application that Mohan started us with. And let's look at the 100 user level. Taken his diagram and formalized it one more notch. So instead of just a orange square where the database is, we've now made that the master database. The next step after about the 100 user level is getting into the thousands of users. And at this point in time, you're going to want to start managing your load a bit. You're also going to want to start considering your failover and your reliability redundancy issues. So there are 3 steps on this picture that you can take, not necessarily one order or the other, but all 3 of them get you to this level. You can add another web instance so that you have 2 web instances hitting the same master database behind the scenes. In front of that, layer in a load balancing capability so that you have the ability to shed load to both of those web instances. And then for failover situation, the example we have here is you have a master database and you have a slave database with RDS. This is a checkbox with different services or with different administrative consoles. There's different levels of this. The key is, from an architectural perspective, have it. Have that slave running so when you get into those recovery modes with your customers out there experiencing your app, because hopefully by 1,000 users you have some customers in the mix, it will be the way of restoring your system. So always planning for failure is key. So going one more notch into elastic load balancing, so what is it? Elastic load balancing is load balancing as a service. It is highly scalable. It is a service that can be put in front of multiple availability zones of instances, and it can balance load across them. It is also something that integrates with auto-scaling groups, which we mentioned earlier. We'll get more on that. And it has a self-healing characteristic and a self-scaling characteristic as well. So it is something that you can start with at the 100 user level, and customers of ours we've worked with use it all the way up to the Super Bowl ad 10-minute peak, massive peak level as well. And all this range is supported by the service. It's a trajectory that a lot of our customers go through on a regular basis, actually. So actually with those patterns there, you can go pretty far. You can get from the hundreds of users to the tens to the hundreds of thousands of users. And what it would look like, just repeating that pattern of doing vertical scaling on some of the instances and adding more web layer, adding more database layer, is something such as this. So you see here that the initial 2 web instances that are in 2 AZs have now grown into 8, spread across AZs, whether that's for your app or not. The idea is that you keep growing that layer, and then independently, the master and slave that were there previously for the database have been augmented with read replicas, so read optimized slaves, where the writes of this infrastructure are going to the master still, and the reads are coming from the reads, the read slaves that are there. You have the same load balancer in front. It's scaled automatically as you progress through this trajectory, and you have the same infrastructure around it all as well, so you can be in the same availability zones too. So as we get here, that's great. We've focused on performance and reliability and availability, but now let's talk about performance and efficiency together. So there are aspects you can do of starting to further building block your system into other chunks. And this is taking us on the path of services. So you can add some services in to shift load around. So a common point that happens at this level of scale is your web layer might have been serving the assets itself. So you might have had your logic running there, and you might just be serving assets off of disk locally. At this point, really shedding that out of your web layer and putting it over to a service that's actually really good at just serving static content, something like S3 is an early option, You can add in another capability such as CloudFront. We'll talk about that in a bit. That's for static and dynamic content distribution across the globe. You might also layer in some caching capabilities. So we'll get to that in a second. And then, as I mentioned earlier, there are points in your trajectory that you might want to layer in NoSQL. But in this app, it's one of the options for really high-speed stuff. So what is S3? Maybe some of you don't know, but S3 is an object storage in the cloud that is highly durable. It has 11 nines durability. It is, there are levels of even durability you can choose if you so like. What it's really fantastic for, as I mentioned, is static object storage in the cloud. So when we're doing the 11 nines of durability, there's an immediate replication across 3 availability zones. So every time you put something in and you get that success back, it has been copied to multiple availability zones, and that's how we achieve that. It's ultimately infinitely scalable. We have customers working at scales that even just a year ago I never could have imagined I would be involved with. And the level of scale is really dramatic that this single service can achieve at the level of durability that you'd want for something to host your front pages of your website. So then there's CloudFront. So CloudFront is a global service. Earlier, Mohan mentioned the edge locations. So CloudFront is a service that leverages those over 50 edge locations to deliver static content and dynamic content. To give you a sense, you can put streaming video in there if you want. There's ability to support that. There's ability to support the static contents. You can sign URLs if you want to do some control over who can access what where. But just to give you a sense of some of the scale, so on the bottom right pie chart, sorry for that, there's a little chart there, and it goes from 1 gigabit or about 1 or 2 gigabits per second around an application that was being offered up through CloudFront to 60 gigabits per second in a matter of minutes, and then back down. That entire spike that customer went through and came back down the other side didn't introduce any more load on their back-end systems, so on the orange boxes we had earlier, and yet they were able to go through that entire thing without skipping a breath. That's where CloudFront gets in of when there are things that are highly cacheable, it will do that on your behalf and then take that heat from your customer instead of getting it onto your back-end systems. One more piece. So continuing with our shifting the load around, as we mentioned earlier, putting in some of these pieces. But if you were to move CloudFront in front of all the pieces, you're going to be getting the benefit, as I mentioned in that previous chart. So you can put it in front of your static assets, and you'll get the benefit of the static pieces. When you put it in front of your dynamic assets as well, let's say you've got search results that are even available, same query in, consistent response out, that you want to have maybe consistent for only 5 minutes. That still will be a benefit that the CloudFront environment can do in front of this same application. So by putting that in there, you've set yourself up to offload the web traffic from your web layer. You've moved some of these things out. You've reduced actually the heat against the database itself, because now it's not the sole thing doing reads for your overall service. And you've started on this path of leveraging building blocks and services that are out in the market. And that brings us to a whole category of services around tools and monitoring that Mohan's going to take us back through. So.
Thanks, Brett. So on this journey we have been on, we started with a single machine, a very small application, and Brett kind of took this up to hundreds of thousands of users, a number of machines, databases, replicas, S3, CloudFront. You can see there's a lot of parts here, right? So next few minutes, we're going to talk a little bit about excuse me, tools and monitoring, so that basically now that you're distributing the load and basically splitting things apart and scaling, we're going to go back to the topic in terms of auto-scaling, kind of where we started this particular talk on when we talked about the web search results, okay? So back to auto-scaling. What is it, right? We kind of skipped over it very quickly at the beginning. It's another service, part of the Amazon AWS portfolio. What it allows you to do is to resize your compute clusters based on demand, okay? And the demand is something that you can monitor and manage through what's called Amazon CloudWatch. It's an included service, which is effectively a reporting tool to tell you how your CPU metrics are, what your I/O metrics are, what your network throughput is, et cetera. And there are some default metrics that we offer. You can also have some custom metrics that you can also pump into a CloudWatch. And all those metrics can then trigger auto-scaling policies and behavior as to how you want to grow and shrink the number of instances that you want. In the bottom right, we have a little snippet of code here that shows this particular auto-scaling group has a min size of 4 machines and a max size of 200, so that as your scale grows, you're going to grow up to 200 machines and shrink back down to 4. Just as a quick tip here, I was thinking, as I was sitting there, is a lot of our customers actually use auto-scaling min size 1, max size 1, so that if the machine were to die, it would automatically restart. You don't have to worry about restarting the machine, right? It's sort of a simple kind of an HA mechanism built into this. So auto-scaling can actually monitor that and grow and shrink the cluster for you. It's a very nice service.
Actually, another pattern on that is if you know in an hour from now you're going to have a big load coming in, just go in and let's say your max was 200 and your min was 4, and you know that you're going to have one of those big spikes coming through. With a single command on the command line, you can say, make the min equal to the max, and then within the next few minutes, all of that will start spinning up so that you have all of that capacity there to process that peak even before it might arrive.
While you're sitting on the beach.
Yeah, well,
right?
Yeah. We get to hit the beach.
Why is this useful, or where does it matter, right? Your website or your application may have this particular pattern, but looking at typical Amazon.com, the retail site, a week might look like this, right? There's typical peaks and valleys. There are peaks during the day, maybe even our evening hours. And if you were in a traditional sort of an IT frame of mind, you may say, you know what, I'm going to provision capacity 10 to 15% above my maximum peak. And that's fine when you're looking at maybe a few days of window, right? If you step back and you see a month, in particular the November timeframe, there's some pretty big spikes, of course, around the holiday shopping season. And your application or your website may have patterns around other times of the year or month or something else. And if you were to provision for the peak capacity now, what you end up with is almost 3/4 of the capacity wasted because you don't need it, and only 1/4 of it is actually being utilized, right? And so if you can follow that blue line, which is sort of mirroring the actual peak and valley, if you will, effectively auto-scaling is the tool or the service, the capability that's allowing you to do that, right? So again, it's a great service that can help you grow instances. We call them fleet, typically when we refer to these machines in a particular context, fleet of machines that can grow and shrink, and scaling them back down. I mean, Brett and I are solution architects. We work with a lot of customers, and this is a big area where we can do cost optimization to make sure that you don't have excess capacity running in the cloud that you don't need, because we can manage and monitor some of this stuff and then be able to predictably grow and shrink your cluster sizes, right? So it's a really nice tool to have in mind. So going back to the picture that we had, what I have drawn here is a little dashed line around the orange boxes, which are the web instances, which is effectively auto-scaling group. So what I'm doing now is saying that I'm going to scale that group based on my application metrics, CloudWatch metrics, and be able to grow and shrink as I need them, right? So you can see there's lots of pieces as we are beginning to talk about here. And you really don't want to do this by hand, right? Again, going back to the tools and monitoring and management theme, there's lots of tools. Of course, auto-scaling is one. There's a variety of other ones to manage not only AWS resources, you know, how my instances are behaving, how my storage is, network is, et cetera, but also from a configuration management perspective, you want to make sure that what you're putting on the instances themselves are also being managed dynamically, automatically, right? And in that spectrum, or in that context, we actually have quite a few application management solutions. On the far left is the convenience scale, and on the far right is control. So to walk you through this, a lot of developers just want to write the code, don't want to worry about any of the infrastructure underlying, how it's going to scale, grow, shrink, all of that. You can use what's called the beanstalk, which is effectively write your code, Java, Ruby, PHP, Python, and then you have a container, and you say deploy. And beanstalk, under the covers, will go ahead and spin up the EC2 instance, set up the autoscaling groups, ELB, databases, whatever else you want, right? So it's a very convenient, abstract concept, a lot of convenience, but not the control that you want to go muck around in the, sort of in the layers, if you will. Moving to the right, OpsWorks gives you a little bit more control, less flexibility from that point of view, and it actually uses a chef framework. So if you have chef recipes and so forth, you can actually incorporate some of that into OpsWorks. Moving to the right, if you want more control, you can use what's called CloudFormation. CloudFormation effectively utilizes JSON templates, and so you have complete control over an entire stack that you want to deploy, and you can define the parameters and a lot of scripting that you can import, shell scripts and everything else as part of that deployable stack. So a lot of folks, they have CloudFormation scripts that are repeatable so that I can spit up dev clusters, test clusters, and then shut them down when I'm done. And finally, far most right is, of course, EC2, which is effectively just machines, and you can layer on anything you want, any tool you want, above and beyond just the bare metal OS, right? So it's kind of a continuum of sort of services that you can utilize in the context of sort of what you're trying to do. And I mentioned host-based configuration management, and I made a reference to Chef. Lots of people use Chef, Puppet. Two other tools that are growing in popularity are also Ansible and Salt. Within our partners developer community, we see folks utilizing all of these, and they're all interchangeable with some of the things I mentioned just in my previous slide in terms of the JSON scripts, layering things on top of EC2. So they're very interchangeable, and the ecosystem, as we all know, is pretty vibrant and growing. So.
And actually, I thought of one thing too, is one powerful combination that we've learned from our customers is to take the declarative approach of something like CloudFormation and pair it strongly with the imperative approach of something like Chef or Puppet or Salt
right.
or Ansible. And the two of those together is where I've seen customers succeed at the highest levels of their automation, is really bridging both of those in some level. So.
Yeah, good point. So as we are scaling, we talked a little bit about sort of the monitoring side of it, host-based configuration management. The other part of the equation is kind of paying attention to the performance, the speed. Because at scale, one of the big things, other things to think about is how is your site, how is my application performing? And that is from your customer, from your end user's perspective, right? And so you need to be able to monitor and manage that as well. And so I made a reference to CloudWatch, which are a screenshot at the top two screenshots there, which is giving you host level and aggregate level metrics as part of CloudWatch. And then at the two little screenshots in the bottom, one is a log analysis tool to collect logs. Analyzing logs is becoming another important area to gain visibility and insight as to what's happening in your infrastructure, right? And then finally, external site performance. How are your users feeling the latency? What are they experiencing by way of impact so that you can actually take action, right? You need data. You need to be able to monitor, to be able to take action on these things to fine-tune your infrastructure as we go forward.
And don't skimp on this. There's many situations where you'll want some visibility, and if you add monitoring after, you can't monitor the past. So to find some of those challenges you might have had for a while is going to be harder if you do it reactively. So try to get at least some level in as early as you can into your thinking, particularly before you get to that hundreds of thousands of user level.
Which actually is a good segue, which brings me to this slide. It's like not having this, it's really like flying a plane with your eyes closed and your wings on fire. It's not a pretty sight, right? I mean, we will walk into many situations where there may be, oh, my database isn't doing, performing well, or something is slow. Okay, let's look at the data, or what's been happening over the last 1 week. What is your IO metrics? Well, we don't have any. Okay, we have to start collecting data. So anyway, at the risk of belaboring the point, just want to say that tools, management, monitoring, all of these are important aspects of architecture and design. And in this context, Marketplace is a terrific place to go in the AWS world. We were talking strictly about management monitoring section here now, but in the global scheme of things, we have partners from business intelligence analytics, databases, I mean, pretty much every spectrum you can imagine that have software available in our marketplace. And many of these you can actually just start up, pay by the hour, and shut them down, right? So take a look. It might be able to solve some of your problems. So now I'm going to hand it back to Brett to take us through the final segment.
Home stretch. So on the trajectory we've gone so far, we can't really overemphasize the tools and monitoring bit. It is definitely a key piece, and it becomes a foundational piece as you get to higher and higher levels of scale. So taking that, however, there are additional ways of breaking apart your solution when you're at this level of scale that really start showing up. And that's service-oriented architecture. So hopefully many of you are already familiar with this, if not all of you, but this becomes a key value for your solution at this level of scale. When you're talking hundreds of thousands of users, you want to start separating out the concerns of your solution into independently scalable services of your own. Amazon.com and AWS, we're internally religious about this for our own services. Everything inside is a very significant service in its own right, and then they work together in a combination for a lot of the experience that goes on. But this capability allows you to scale pretty much to no end. So if you start coarse today, where you might break, as we mentioned, even the services of web layer to database layer, but you continue on maybe asynchronous and synchronous tasks, and then you continue on asynchronous tasks that take longer than 10 minutes, synchronous tasks that take longer than 10 milliseconds, all these kind of ways of carving it up without even knowing what your application is, just taking those chunks and thinking of those as ways of splitting up your solution becomes a very powerful way of continuing to scale beyond the hundreds of thousands of users level. So there's another capability as well that starts showing at this level that if you hadn't emphasized previously, you really should start emphasizing at this level of scale, and that's loose coupling. So to give you an example, instead of controller A speaking directly to controller B, as a system scales, just that simple act alone of them talking directly to each other, if you can separate those out with some intermediary, so the case at the bottom here where you have loose coupling where a message arrives to controller A then does something, produces out another message that then is an input to controller B, allows both controller A, controller B, and the message infrastructure to scale independently at different points in your solution. So that does two things. It's the scale piece, but it's also optimizing the cost for where you're at on this dynamic trajectory we're talking about going up and down with. So the ability then to use services becomes a key capability towards continuing to grow. So the key here is also, if there is already a service that meets your needs and it is delivered to you in a way that scales up as you use it and scales down as you don't, use it. It is not something that I would suggest is going to add value to your bottom line to do email yet again for your infrastructure. There are a lot of services out there. There's some on the marketplace, a lot on the marketplace, but there are a lot out there. Take this point in your architecture to start introducing those services if you haven't already, and earlier if you can, if they make sense. But the key here is as you add those services with loose coupling, then you actually can start working at this higher level of scale as well, where you're using your internal services you might have made, using third-party services, but your customer experience continues to grow and your pace of innovation is actually accelerating as well, because you're getting more and more focused on what truly is unique with you. So on reinventing the wheel, I'm just going to say this one more time, if you're making a queue, DNS servers, database, email, infrastructure. Pretty much just don't. Just don't. So I'm the lucky guy who got to deliver all these messages today. So just don't. It's really not something anymore. It's like, I think of this as it's the string parser. You don't want, who wants to make a string parser, right? Good, no hands went up. So it's just not the thing that anymore, these things you really need to do. There's so many choices out there. It's not something you have to go do. So back to SOA. So when you're at 1 million users, you need to start thinking in terms of services, as I mentioned, but you also need to start thinking in terms of all of the things we've spoken about up until this point. So you're definitely going to want to be multi-AZ. Think of that as if you were scaling to millions of users anyway, you'd be running in multiple data centers. We just give you that ability to start really early with that and continue that, get good at that, right? Understand how that works. That's an automation, a scaling problem, a reliability benefit, but it's all those things mixed together. You're also going to want to make sure that you're continuing to serve content smartly. Sometimes as you might have done a little bit early, and then there's no problem and you keep growing, kind of revisit that at that 1 million user level of are we still serving our content smartly as its own concern, as its own aspect of your service. Cache off of the DB at this level. So even though SQL is still at the core, you can go really far with a lot of the results that come out of it and cache it in another layer. We have Elasticache, as I mentioned earlier, that supports Memcached and Redis. There's other caching mechanisms built into databases increasingly. And then move the state off of tiers that also auto-scale. So you can run, instead of thinking of it as running one big box to do really important stuff, try to split it into that same box into 3 smaller boxes that are all stateless and still accomplishing it. But if you lose one, who cares? When you start changing your thinking in that way, you're on the path of the elasticity you get from auto-scaling, but you're also on the path of failure, recovery, et cetera. So this is one way of looking at 1 million users. This actually already ignores an availability zone. There's only one AZ on this picture because the other one just wouldn't fit. But what you see here is there's all the concepts brought together. There's auto-scaling groups are the white dashed lines. In the upper left, that's the same auto-scaling group we've had through all the other pictures. We're ignoring the other AZ. So what's also in here is you might have an auto-scaling group that now has separated out your application logic from your web logic or some section of your service into its own. Let's say it's an asset service or a lookup service that's separate from your web tier. You want that to be wrapped in an auto-scaling group as well if you can. And then you might have a worker tier. That worker tier is yet another auto-scaling group that shrinks and grows based upon the number of messages that are in a queue or based upon the number of queued up outbound work that it has to produce. It might scale up to get past, I think of it as the snake just recently attacking the alligator and swallowing the whole thing, and then it scales back down when it's done, right? Those kind of things are most likely showing up at the 1 million user level in your infrastructure, and continue to leverage things like the off-the-shelf services like we've been using the example of SES might be one, which is a simple email service from us, or S3. So now, the next big steps. 5 million to 10 million, continuing with everything we've talked up until now, but at this point is when SQL starts showing a bit of its top end, at least based upon most of the I/O you can give it, most of the capability that you give it. But there's still tools that you can use to kind of keep growing up above this level. There's federation, essentially taking your database apart by function and putting it in different separate pieces, and then possibly within those federated databases, you can have sharding going on. You might have one that has all sharding in it. And there's also, at this point, again, you might have obvious needs of taking, everything would be great if that one table just went away, right? And because that's the hot table, and it's really really eking out all the performance you want. It's stealing it from everything else in the same database. So that would be a time of possibly starting to leverage a NoSQL as well. As you think about NoSQL, you can actually think of NoSQL as the point in your architecture where you might federate anyway. Because in one perspective, NoSQL is actually federation. You tend to separate things out by function. They're highly optimized for that function. A really good use case here is the voting application. It might be the leaderboard or the scoring application. It could be session state management, like you've had that in your database the whole time, and now you just got so much, you got 10 million users you're looking at. You really need to get that into something that's both durable and hot supporting at the same time, and that's where NoSQL really starts to shine, all those kind of things. And there you have it, 10 million. So quick review. What did we go through? I already went through a bunch of this, but let me emphasize a couple more things. Caching data inside and outside of your infrastructure is a key capability that sometimes gets lost as we're in the heat of battle of going up this trajectory. So thinking about it earlier, and even if you're just caching little things, having that skill on your staff, I mentioned staff earlier as a key aspect of scaling, having that skill on staff of knowing where to put caching, also using automation tools. The automation person in a lot of these companies, the better those people are, the smaller the team can keep going and the faster innovation can come out on massively large infrastructures. I've seen that pattern again and again at customers. And as I mentioned, you're most likely going to want to start with SQL because you're going to want to get help early on, and that'll be an easier way of getting help. Continuing with the review, definitely layer in service-oriented architecture. Don't reinvent the wheel, please. Don't. I see too many customers get stuck in a situation where they have something that's 99% of the same as a lot of services out there, but they made it themselves, and that's the thing they're focusing on versus delivering benefit for their customers. That becomes a key sticking point as you go up. And then definitely move to NoSQL when it makes sense. It is a fantastic capability for what it does, and case in point, DynamoDB has no top end. There is no top end to DynamoDB. You can't outscale it, period. And then putting all this together, you can actually handle 10 million users and possibly even go beyond. So let's talk about what it would look like to go beyond 10 million users. At this level, I mentioned earlier, SOA, maybe you've got your asset service, but now you're further decomposing your services into individual independent services. That might be another way of continuing your service-oriented architecture. I'm going to jump to the last part here. This is one that the sooner you can do it, when you start thinking of the millions of users, you or a team or an individual or some service or some capability should be able to give you deep analysis of your infrastructure. It's not the same as monitoring. This is, it's like nerdvana. It's where you or somebody are so in tune with the metrics coming out of your infrastructure that it's the ability to analyze the glitches in the matrix as they're going on instead of having to deal with them after the fact. So at the 10 million user level, you're going to have somebody in your staff who is able to do that for you if it's not every one of you in this room. That becomes a key value early on, finding that person, finding that infrastructure perspective to give you for your application that allows you to keep going beyond 10 million users. So what are next steps? I would say that this trajectory here today follows the most closely of starting at the bottom, the startup examples we have there, going through the architecture patterns. We've got a lot out there. There's some in this deck. This is going to be posted. There's a lot out there as well, which are architectural patterns that are at different levels of scale. And then use the documentation as a reference or as a focused deep dive when you're maybe striving for deep analysis. I always like pointing this out. There is a free tier. I don't know out of the 30-plus services we have, exactly how many, but a lot of our services have a free tier component to them. So if you are growing up your millions of users and there's one of these services you wanted to explore as a possible benefit, a lot of times you're going to be able to try that free. You're going to be able to go out there and try that and see if it actually fits before having to pay for it as well. And then ask for help. We're here. This whole event is all about helping. Is all about helping our customers succeed more. There's a forums out there. There's definitely a support. There's your account manager. Whether you know this or not, every one of you who has an account manager. So you can leverage that account manager. That account manager then is the way you can get in touch with an SA. So we're here to help as well. We're included in the price of everything that you use from AWS platform as well. So thanks for listening.
Thanks. And we'll be up here for a bit.
About,
So you guys want to come up and ask questions.
about 10 more minutes, we'll be up here in the front.
Thanks again.